Does anyone know where is a add field button if they're working with QGIS?
Sir, I think when we open the attribute table, in that uh, there's an option of adding. It's in the end, towards the end, there's one icon.
Sir, even when you are creating the feature, if you press that add field there also you can press it. So,
We can add more than one fields there.
yes, sir. So if we
Um,
are creating a new field, even in,
for example, layer, create layer, new shape file. Maybe I'll call it polygon to geometry type polygon. We call it a country.
that
Um,
here add to fields list is there, no, sir. You have to press that. Yes, sir. So
okay.
it is.
So in the polygon, just add one layer called as country. Keep it as string. Now I'll remove these two. Mm, yeah. So let's create three polygons. Now in the attribute table, uh, let's name it as maybe India, USA, and China. So we have three polygons with these three names. Now this is an attribute of this shapefile. For example, now we create a new one layer that is point 2 and we select point. Here, if I add first a person and keep it string and I add to the field list, then I add another that is again country and I add to it. And then I add the third one that may be, let's call it uh, GDP ranking. So I have uh, three, like other than the ID, I have three fields for it. Now, let me create 3 points. I can also fill it here, but I will do it directly there. I'll just call it ID1, ID2, ID3. Now, when I go there and in the attribute table, I say, for example, first I fill in the countries the same as from that one. Any order, maybe it can be China, then I say India, then I say USA. Uh, is it just a capitals, right? So maybe the person Rahul or maybe the person Zing Li is from China. From India, it's Rahul, and from USA, it's John. and we give it the GDP ranking 2, 1, 3. Now I have now I have two shapefiles, but in one of the shapefiles, that is my point layer, I have some attributes. These are just three attributes. Maybe, for example, you have such a data that you have like 100 or 1,000 attributes, like there may be 1,000 columns, and you want to add this data to the data of the polygon. So, how to do that? That is called like uh, putting this data into the table of this data is called as attribute join. There is defined ways known as inner join, outer join, but they are more advanced. But for now, we just need to understand the very basic that these are our attributes and both we are just joining the attribute of one to another. So now, uh, because I see in polygon 2, there is just the country. Now what I'm going to do is I will right click it and go to properties. In properties, you'll find joins here. So I want to add data from point 2 into polygon 2. I click this plus. Now I'll select point 2 and the field I want to join. So both of them should have one common field. In both of them, one common field was country, right? So I'm going to choose country because the others were not common. So the process will not happen. To to proceed with the join, we always need a common column. So in this case, we had country. Target field also as country. Now we have option here. This is an option like in case you don't want all the fields to join, you can just select I just want these two fields from this one to come to here. But in case if you want all of them, you just uncheck it. If you want some of the fields, just select some of them. Okay. And this is, for example, uh, if in your new table, like in your polygon, you want the new fields that to be added. So, for example, if you are checking your data later on, if somehow maybe after 2 months you are checking your polygon two attributes, and you want to see, okay, there was some data that I had moved from point 2 to polygon 2. So, if you want that, in case you can just if you uncheck, it will automatically the new column names will be point to underscore. I will just explain it. But if you want it to be something else, you can just change it from here. So I will go with the defaults. Now I will press OK and I will do apply. Now when I go to polygon 2 attributes, what do I see? So from point 2, I have I have its IDs from here. I have the name of the people extracted from here, at the GDP ranking extracted from here. So you always need to have a common reference column to do this. And this is called as join, attribute join. In this, anyone has a doubt or anyone was left behind or something, please let me know in the comments. If it's all good, just all good. Okay. Uh, so in the future classes, we will study about what is you will in your when you'll start with your programming, you'll this attribute table is kind of a same format that will come in SQL also. So uh, for now, I just joined it based on a common column. But what if you want certain part of the data to be joined, or there are some kind of ways to how to join it. So that is for just for information now, that is called inner join, outer join, but that will come in future classes. But if you particularly find interesting, you could just go to explore it. Inner join, what is an inner join, what is an outer join, and there are even further types to it. So we are done with this part from yesterday. Now what we talk about is the coordinate systems. Though we covered it before, quickly give you a recap, and then we'll do reprojecting a shapefile. How to reproject a shapefile. Now, uh, yeah. So if you remember, there are two kinds of coordinate system. Two kinds of coordinate system. One is a geographic coordinate system. The other one is a projected coordinate system. So just try to remember or say it like whenever the word geographic is attached with coordinate system, just kind of try to think of latitude, longitude, like a geographic location. Whenever you think of projected coordinate system, okay, think something is projected on a map and think of it as a in map. So this is a geographic coordinate system, always like latitude and longitude, and a projected coordinate system in meters, northing and easting. So the term here used is northing and easting, latitude and longitude. So you know the divisions, right? So when we talk about the geographic coordinate system, the Earth is not a complete sphere. It is, it looks like something like this, and it has lows, maybe like in the oceans it has very lows, whereas somewhere it has the maybe like mountains or it is Himalayas. We add a system to it just to understand it. We cut the earth into these slices and call it latitude and longitude, but we create like a reference system to it, and that reference system, it can be a spheroid, it can be ellipsoid. It depends on us which one we are using. So, depending on the reference system that we are using and combining it with the geoid, the combination has some rules and laws that are with the higher ups, like that doesn't concern us. But how they're combined, it forms a reference model of the Earth that is called as datum. So this reference model has latitude and longitudes. For example, if there is a position here that is 30° north and 30° east, that position in this place, if I change the ellipsoid to a spheroid, that 30° north and 30° east will change. So like two different datums, but same lat long will be a different position. I hope you understand that. If I'm using a spheroid instead of ellipsoid, or like consider both, in one case I'm using ellipsoid, in one case I'm using spheroid. So combining it with this, it forms a reference model because it has its highs and lows. These, the lat long that it cuts into this one is not the same that would be same like for the spheroid model. It will be different. So if there is a place 30° north, 30° east. It may be your home in this 30° north and 30° east. But in the spheroid model, that 30° north and 30° east will not be that place. It will be somewhere here, there, but not exactly that place. So this is fixed. You can't change the shape of the earth. This is something that you could that you can add. That depends on you. Ellipsoid, spheroid. There are many other models also. Maybe there is one model called as echinoid also. So just the 2D version of it. This is your geoid. You place this on the corner of it, and in one case you place this in the center of it. The placement of this on this. If if you are just going to do your analysis, maybe you live in USA and USA falls here, and you are just concerned with USA and you need precise calculations. So what you will do is you will select this kind of datum that is called local datum, where you place the ellipsoid, the reference model, onto your area of interest locally. So if you have if you're going to do some analysis here, they will be highly accurate. But instead, in this only, if you go to the other part of the world here and do the analysis, so the lat long, if you try to find here, that will be highly inaccurate. Whereas, for example, if you're working with something, you're working on a big project that you need to take observations all around the earth. You don't have the time to do local datums many times and then convert into one datum. You just have to do many things at one time. So you'll choose the geocentric datum. It will be like in this case, if you're taking an observation here, but in this case, an observation here will be more accurate than this one. So overall, if you have to take an observations all around the globe, you have to do analysis all around the globe, then geocentric datum is more useful. And 99% of the times we are using WGS84 only. It is in very rare cases that someone is using a local datum. So as I said, that the same lat long will be a different location for different ellipsoid models, for different reference models here. So someone used a global coordinate system, NAD 1983, and then they used NAD 1927. So just look at this white thing. In this one, it has its location to be, the ending is 6 degrees, whereas in this one, it's near 1 degree. Here it was, the upper one is more near to 9 degrees, whereas in this one, the axis has shifted downwards. So this is called as distortion. Distortion due to geographic coordinate system. So some same distortion will occur in projected coordinate system also if you use two different kind of coordinate system. So we are done with geographic coordinate system. You think of Earth in lat long reference models, and whenever you talk about lat long, it's a geographic coordinate system. So now you're trying to represent, now we'll talk about projected coordinate system. Now you try to represent Earth on a plain paper. So there are three ways you can do it. Just think of a paper. Maybe like you call the paper more of a map because you are working on your computer. It is a plain screen, right? So you need to view the Earth on a plain screen rather than a curved surface. To make observations, you do things on a plain screen. So think of this as a map, or you wrap around your map around like this. And if you project the areas on this, like this shadow part on this plane, that is called projected coordinate system because you're projecting the area on a map. So there are three ways to do it. So all of them like this one is called planar, this one is called cylindrical, this one is called conical. So because a map always has a x and y, you can consider an origin anywhere and it has two directions, Cartesian directions, that is x and y. So because having an x and y, so it has a linear unit of measure. Unlike geographic coordinate system, it had lat long. For this one, we have meters on x this much, on y this much. Now, you can place the paper on like a very top, just touching a point on the head. So that in that case, the projection on that paper, that map would be called as a result of a tangent case. In case your area falls like to a very narrow zone and you're not concerned about taking any analysis in this part, you just want using a planar projection, but you want more accurate analysis of your region. So you could slice the paper through the globe and just this shadow part is being projected here. You're not concerned about this. You'll just take a part of it later on and you'll see, you'll do your analysis. So this case is called a secant case. Similarly, in cylinder also, if it touches around, just around the diameter, it is called as a tangent case. Whereas if it cuts through it, it is called as a secant case. So cylindrical projections are also called as Mercator projections. They are also called as Mercator projections. Now, if the cylinder is placed like this, but we mostly use something called as UTM. Now, because we want to use UTM, that is like in geographic coordinate system, I told you WGS is used very much. Like 99% of the times in geographic coordinate system will use WGS 84. Similarly, if you're working in India or neighboring countries, you'll be mostly using it the UTM, that is Universal Transverse Mercator. Now, what that actually means is instead of your horizontal circle, you place the cylinder in a position like this, you're cutting through the poles. And when you cut it, maybe you rotate it by 6 degrees. You rotate the cylinder by 6 degrees, and every 6 degrees, then you get a strip and you take out that strip of paper and you put it around a globe like this. So this is what defines the UTM zone that we looked on onto Google, like find my UTM zone, and we it asks for your location, and we saw it before two times that it will take me to UTM 43. So similar for a conical projection, uh, we keep a top, and if it intersects it at one circle, it is tangent case, and similarly here in Europe. Like we are using UTM mostly. In Europe, their position is such like the countries placed here, like Iceland, Finland, they are most preferably using a conical or planar projection. They are not much dependent on UTM. They like to use more of a conical projection. Like in Austria, there is Austria Lombard. So I explained this part before only. Now, uh, please open your QGIS.
Sir, UTM is a tangent case or secant case, sir?
Uh, So placing a cylinder around is a Mercator, but we do a universal transverse Mercator. It is a tangent case. It goes around in one circle to it.
Oh, yes, sir. Sir, then if we are doing a tangent case, then um, the uh, top part and the bottom part will be like extended, right? That's why, like in our map, like we have extended North Pole and South Pole countries. Is it like that, sir?
I didn't understand you, sorry.
Okay. What I'm telling is that so if we are uh, projecting in a cylindrical projection,
Yeah.
then uh, it is it true like only in the equator area the distortion is less and the northern and southern areas the distortion is more. Is it like that, sir?
I will try to explain you this again. Maybe I'm
Uh,
not able to properly get your question, but see, um, I have this around, this is a piece of paper around the globe. Now,
okay,
what
sir.
I do is I move it like this by 6 degrees. I move it uh, here, I move it by 6 degrees. Here, I make an angle of 6 degree.
Okay, sir.
Consider this point as this point here. Okay. Now,
Okay.
at this 6 degrees, it will go and again go and down, connect like this. This will form a strip. This strip is shown here, this strip.
Okay, sir. Yes, sir. So we are taking from the middle this way.
So
Yes, sir.
when I move it like 360 degrees, 6
Mm-hmm.
into 3, 6 into, sorry, it forms 60 strips around the globe. So when I move it like for 6 degrees, it is 360. 60 into 6, 360.
Mm.
Makes sense for you?
What I'm asking is, yes, and I understand how it is done,
Mhm.
but I'm telling in terms of size and shape of the um countries.
I'm really sorry, like I'm not able to get your question.
Okay, sir. So, this one I understand, sir. So, we are doing this 6 degree, 6 degree. I'm telling that there will be distortion, right? So, the distortion, what kind of distortion we'll have in UTM, sir? Whatever projection we use, there will be some kind of distortion. And in some kind of distortion, like we will, the size will be almost similar mean size of the land where we are in like if you are considering Asia ka size, not even Asia, that
You're talking
latitude
about the
area.
distortion that, okay, okay. So,
Yes, sir.
okay, okay. So, what is it like? Uh, just consider this thing when it is projected on this cone, whereas the same thing being projected on this cylinder. So, for example, you see the shadow part, that is what is being projected on this paper. So,
Mm,
the projections, for example, if the area of a region, maybe Iceland in this globe, it
mm,
has an area of, just assume, 100 square kilometer. So when
mm,
it is projected on this map,
mm,
it will form some area. It will be not exactly same as 100 square kilometer. And in this case also, it will form another projection area. And the area in both the projections will not be the same. Though Iceland in real life, in on the Earth, in reality, it is 100 square kilometers. But in both projections, it will have different area. So now we know that the area of this in real life is 100 square kilometers. So the people higher up, they have used some calculation in this projections that whenever we open this projection in QGIS, that that area will always come as 100 only.
Okay. Ah, yes,
But
sir.
when you look at it, it will, when if you open this map on a table, they
Hmm.
will not look like what they are on actual Earth. They will look maybe bigger or smaller. So depending on their geography, on which part
Oh,
of the Earth they are, they will look weird.
okay, sir. But when we calculate, we'll get the same,
Yeah,
like if I land.
because that thing has been added to the software.
Ah, okay, sir. Yes, sir. This is what I was asking. Yes, sir.
Okay.
Thank you, sir.
Okay. Now please open your QGIS. Mm. In this coordinate part, just select all and write, maybe write world in short. Come. Yeah, this is showing the wrong one. Let's remove it. Maybe just go to your XYZ tiles and uh, drag your OpenStreetMap here. Now go to any of the locations. For me, as example, I always take Chandigarh. Let's go to a particular building. Okay. Now I create a new shapefile, that is point. I choose the geometry type as point. Um, let's for our study take it as 43N. This is 32643. Also select here 32643. Take any random building, just select, just try to keep it like a single polygon. Yeah, like this one. Now, uh, create 4 points. Save it. So you go to your properties and you check in your source that we had selected 43N. Now if I go here, okay. Now when I save this file, maybe try to save it again, go to right click, export, save feature as, give it a name as you wish. I'll call it point demo. Mm, choose a location where you will access it because we're going to access it now. Demo 3. So I save it here. You can remove this one. So I have point demo. Now, mm, create a new folder here. Just copy SHP, SHX, and DBF. Also, mm, just open a new QGIS here. Now I take the SHP to my new QGIS. So this time it is not being associated with any coordinate system. So sometimes you'll be getting any file like which does not have the projection system. So how to define a projection system? Then in that case, mm, go to vector in data management tools, go to reproject layer. In vector in data management tools, go to reproject layer. Or I'm not sure if there is a simple way we could just write it here. Reproject, reproject layer. Yeah, there are two showing up, but I'm not sure which one here it is. But I know that it is the one here. Mm. You go to vector, data management tool, and reproject layer. Now you have your point demo, and if you remember, we did it in 43N. So what will it do is it will create a new file and add this projection system to your file. If I go here, I select Google Maps, I go to this one. See, uh, it is here, but this one is somewhere, even I don't know. So just remember, uh, even if it already has like this as a projection system and you want to reproject it, you can again do the same operation. You can reproject layer. I choose this layer again and I want to this time maybe convert into some only just WGS84. So even if it already has a projection system, you can still do it and it will create a new file. So now you see the difference here. Uh, the map is in 2326. Since the map is in some different coordinate system, these points should have been here and it is showing them somewhere else. Now, if we choose it to the one that we created, that is, we created the files in 32643. Okay, we created an OpenStreetMap, sorry. Yeah. So, but you understand the point here, right? You can do the reprojection if you don't have the projection system. You can also reproject the already projected file. And until now, if anyone has a doubt, please let me know in the chat or directly. Just say all good. Okay. So now we move on to the cartography. That is the map elements, symbology, thematic maps, region, scale. So I'll show you for now today I'll give you an example in ArcGIS Pro, but we'll make a layout tomorrow. So I will use ArcGIS Pro just for your understanding of what these are. But we'll do the same in QGIS layout tomorrow. And let me explain you ArcGIS Pro. For example, this is someone's land parcel, like someone owns this box. These are land parcels, like these boxes. Because of river, there's not exact shape, but like this is the ownership of someone. They own it. Now, in case we want to create a map, for example, this is your study region or something you want to do for your research paper or maybe for your thesis, and you want to present it on a map. And in a map, there you can whatever is on your screen, or you want to add different elements or delete elements or change the base map. For example, you could choose a navigation base map. So in our case, we are going to choose the imagery one. It looks more sensible in our particular kind of data right now. So if I want to give this map to someone, so do not worry how I'm doing it here. Just try to understand, like, a layout is the like a page layout, like you have what size you want your map to be. So there are various different sizes, right? If you want just to be creating a A4 size map, you can choose this. So as we go to uh, the smaller dimension of A, it gets bigger. So, for example, in my case, I will choose A0 landscape. Now it is chosen. Just a moment, I need to plug in my laptop. Yeah. So once we have chosen the layout, this will be same in QGIS. After choosing a layout, we will add a frame to it. That is the extent you want your map to be. For example, here I want it to be until here. Now see, this map is being represented here. Now in both QGIS and ArcGIS, there is different way to uh, zoom it, pan it. In ArcGIS, there is something called as activate. And in QGIS, we just have directly a thing that will do in practically tomorrow. It is something similar to the activate only. When I click activate, now I have the capability to zoom to my area. Just close activation. Now, what I feel is like I'm not able to view things here. So when you open your layout, your map elements add up here. And you can work with your map elements here. Like if I want to customize this, I wanted to make this more darker. I want it to show the labels. Anyways, the labels are not showing. I don't know why. But in case, now there are elements to a map that you add. For example, there is this north arrow. So always in most of the maps that you will see in your life, they always have a arrow that directs to the north. So depending on your choice, you can choose. For example, this one does not look nice. So we try to make our map look nice. We choose this one. Well, maybe place it here. So it depends on you where you want to place the thing. So there is something called as the scale bar. So in a scale bar, for example, I choose this one. It's not visible. So what this scale bar is doing, it is telling me how much this is actually on the map. For example, From here to here, if you just take a reference length from here to here, it is 0.16 kilometers. That is 160 meters. So this is a length of 160 meters. So this is called as a scale bar. It forms a part of the map elements. Then we have one is the north, one is the scale. Then we also have legend. So in the legend, it defines the because I have taken A0, the page of size is very big. So if I would have taken A4, this would have uh, this text and these things would have been smaller. Now I have to edit it to make it bigger. But what a legend is, now it tells us like what is all included in my map. So here I have a Killa number, that is the plot number, and the polygon of the plot. So legend forms the uh, textual, like what data is here, the concerned data. So other than this, you can always add a title. For example, in my case, I will add plot information. So let's try to do this again in a A4. Insert new layout A4 map frame. I define the map frame. Now in this, I choose a north arrow. I choose the scale bar. So here to here, it represents 120 meters. I choose a legend. And place it there. So I give it a title. So similarly, there is an option to add grids to it. That we will learn in QGIS that how we add lat long to it, latitude and longitude grids. Um, but mostly in a journal basic map, you just take your view. These are the 4 or 5 elements that you add to it. That is the title, the legend, the scale, the north arrow, right? And in QGIS, we need to install a plugin to also. There is a way to do it quicker by installing a plugin. Mm. So I hope we'll do the practical on how to make a map in QGIS tomorrow. But I hope for now, the part of understanding what is a legend, what is a scale bar, what is symbology. Symbology refers to basically the uh, how you customize your shapefile, how you will make this look. Like in this particular case, it is not looking so nice, but the beautification of the map is how you do it. So uh, these are all symbologies. Like if maybe I want to change this point, green point, how it looks, I want the color to be maybe pink. So the customization of the vector files that or the raster file that you have added to your map is called as symbology. Um, until now, does anyone has a doubt? Please let me know. In case it's all okay, just let me just say please all good. No, no, okay. So for people who are experienced in GIS, I feel that this would be like very boring to see a map. But if you're very new to it, it forms the basic how a map looks, right? And there is something also in a scale bar. So the representation of a scale bar is the one I showed you. It already showed how many kilometers it is. But sometimes the scale bar is like saying a ratio, 1:50, 1:100. So, uh, for example, the one I showed you today in the map, it was this one. That this 0 to 300 kilometers shows the range, like this area is 300 kilometers. But this one is your homework that you have to tell me tomorrow what these ratios mean. The scale bar, if someone has a map with a scale bar in ratio, what does this actually mean? And one another thing. Has anyone among you created a map before? Uh, you have created a map before? Yes? Okay. Um, so you all are familiar with the map, then I should understand. Or are there some people who are very new to this? If there is someone very new to this, please also let me know. Like who is doing the GIS for the first time, or uh, they have to understand maps. Maybe just show a thumb or something if there is someone like this who is very new to it. Okay. So the question I asked, the ratio, does anyone know? Because I see you have made maps already. So do you know what the ratio is?
Yes, sir.
Explain.
Like 1:50 means one unit on the map is equals to 50 units on the ground. The unit can be anything.
Good. So it is mostly that the definition is right, but mostly it is more likely 1 centimeter is like if I say 1:500. So mostly it is 1 centimeter of your map. It represents, it can be taken as any units depending on it. but they do not mention it. You have to figure it out yourself. But it could be 5, but generally it is, if it is representing here like this, it could be mostly 1 centimeter represent 500 of the same units, but it can be anything else also. It is not necessary. So in case of ratios, sometimes you have to also figure it out. Okay, what can it be? Okay. Okay. So tomorrow we will do is, uh, tomorrow we'll create in QGIS layout, we'll create a map. We'll add all these things. And also we will have, if we have time tomorrow, we'll have a look of the Snap software and Sentinel Hub. Okay. So for today, we are done now and we'll continue tomorrow. But if anyone has a doubt, just let me know in the comments, or uh, we'll see each other tomorrow. Okay.
फंक्शन तो इनका है ना, इनकी तरफ से फंक्शन ना, तो फोटोग्राफ फिर तो ऐसा है कि सगाई पर आप फंक्शन फोटोग्राफर भी वो सगाई वाले पर फिर तुम लेकर लड़की वाली।
Sir, I have one request to make.
Yeah.
Tomorrow I won't be able to attend the class, so if by chance you'll be giving any homework or assignment or something, so please share that in the WhatsApp group also.
Okay, okay. And in case you'll be having the access to recording also now, all the time, every day we are recording the lecture, right? So
Yes,
you
sir.
can ask for the recording from Nagendra.
Yes, sir.
Okay, okay.
Okay.